Good afternoon, guys. I hope everything's all right today. It was a nice day. And now we can focus on some nice coding as well. As you've seen, I showed you a tweet of Michael Jackson. I guess it's a different Michael Jackson though. Hi, Alex. Um, yeah, you should also click on that small, what is that? A heart that will follow, that will make you follow me. You should do that. Thank you, by the way. Uh, yeah, so people seem to be liking React components a lot. Sorry, but ECMAScript 6 classes. Uh, there's this pool, it's 1,500 votes, and about 47 people say they use ECMAScript 6 classes outside React components, which is kind of interesting for me. I would like to know if it's because they come from a Java background or other OOP background. Otherwise, I don't know, like 25% is using them all the time. As you know, I'm not a big fan of classes. I prefer functional style. I prefer readability. I prefer elegant code. As you might have seen, today's stream name is based on software craftsmanship manifesto. I kind of discovered it not that far away, but I really like it. I love the first point, not only working software, but also well-crafted code. I really like that one. That's what we aim for. Like making a code functional, functioning is easy, but make it well-crafted, that's something. Right, okay. That was some nice introduction. Now let's dive to some coding. I will repeat what I do. So I'm using exercises from the site called Exercism. It's really nice because it has some tracks, and in each track you can, maybe I can show you, in each track you see like solutions, and you see our people solutions, and you can comment on that, you can have iterations. So I think it's really nice for collaboration. Last time, I'm not sure I can see my progress. Oh yeah, here it is. This is what we did last time. We did Roman numerals, and now we are moving to the next one. So let's see what it is. So this will download the newest kata for this track, and it's called CircularBuffer. Okay, let's see. I will also immediately start downloading that yarn packages, and let's see what they say. Whew, that's gonna be interesting. CircularBuffer, a data structure that uses a single fixed site buffer as if it were connected end to end. Circular, yeah. A cyclic buffer or ring buffer uses a single fixed site buffer as if it were connected end to end. Yeah, we read that. A cyclic buffer first starts empty and of some predefined length. For example, this is a 7-element buffer. Okay. Assume that a 1 is written into the middle of the buffer. Yeah, exact starting location doesn't matter in a circle buffer. Then assume that 2 more elements are the 2 and 3, which get appended after 1. 1, 2, 3, yeah. If 2 elements are then removed from the buffer, the oldest values inside the buffer are removed. The 2 elements removed in this case are 1 and 2, leaving the buffer with just 3. Okay. If the buffer has 7 elements in it, it is completely full. When a buffer is full, an error will be raised alerting the client that further writes are blocked until a slot becomes free. Okay. The client can opt to override the oldest data with a ForceRight. In this case, 2 more elements and B are added, and they override 3 and 4. Finally, if 2 elements are removed, then what would be returned is not 3 and 4, but 5 and 6, because A and B overrode 3 and 4, yielding the buffer with Yeah. Okay. I'm not sure how that differs to a queue. When you have like elements 1, 2, 3, 4. When you add element, you put them at the end. When you remove element, you remove it from this position, like from the beginning, and then when you, oh I see, when you are full and you force it, you kind of move something and force these in there. It's like a, yeah, I think it looks like a very much like a queue which just has this. I think we can implement it like that. But let's see the test files first, because there we will see the actual API and the actual examples. So what we have here, CircularBuffer from CircularBuffer, buffer exception as buffer exception. What is this? Oh, this is not nice. Okay. So first thing we do is that we make this a little bit nicer. Yeah, that's nicer. Interesting. CircularBuffer. Reading an empty buffer throws empty buffer empty section. So you have CircularBuffer of size 1, and when I read, it throws an exception. Okay. Write and read back one item. So you create a buffer of 1, you write number 1 as a string 1 actually. You read it, you receive that 1, and when you try to read again, it throws because it's empty. Okay, that's, I guess that's okay. Here I have buffer of size 2. I write 1, 2. I expect it to be when I read 1, then 2, then exception. I can, oh, it has a function clear. CircularBuffer 2, write 1, 2, clear, read, exception, 3, 4, 3, 4. Yeah, write, read, write, read. Yeah, it seems to be pretty straightforward, I guess. Oh yeah, null and undefined are ignored for some reason. And writing to a full buffer throws a buffer full exception. So when I try to write and it's full, it's an exception. I have ForceRight. Oh. Yeah. I'm not sure, Alex, if I wrote it, the comments of yours late, or I already did that, or I missed something. Yeah, it seems to be ForceRight. Yeah. It's 2. We have 1, 2. You force 1. That means that the 1 is removed. Then it's 2 and A. Okay. ForceRight, X-like writes and non-full buffer. Okay. So it basically ForceRight is, and write is the same. Just write kind of raises exception if the buffer is full, and then here with like some combination which seems to be not that difficult. Okay. Okay. So I will create a file. So as you see, what I use here, oh, they don't even like use it. This is the first exercise from this side that doesn't want new here, which is great. I love that. I never like that. I always like to use this. I mean, I use the same approach, but it felt a little bit dirty. Now it's not like that. So we will receive size, and what we will return, we will have this revealing, we'll use this revealing module pattern. That means we will have some variables which would be in the scope for this package, and we would return an object. We might freeze it. I think it's a good practice to freeze it. I will not freeze it right now because it makes it longer and doesn't change nothing here, but for a production code, freezing would be good. And here we would return the functions. So one of the functions we need to have is write and read. write and read. Okay. What I don't like about this is that it mutates the buffer, right? The read mutates it because it deletes also. Write obviously wants to mutate it, but I would like to write it pure. So what I'm thinking about is that here I would create a mutable thing. I would call it buffer, let's say, and that would be an empty array at the beginning. And this function, what they would do is that I would write a pure counterpart, run it, assign the new value to buffer, and then return it. So it would look something like, so write receives item, and what it does two things. We can write it maybe better later, but now let's work with this. So something happens. I see that we are offline. How is it possible? Are we having some problems? I'm not sure what's happening. And I'm not sure if you can see me now. Okay, it seems that it's... Okay, so my system was like kind of weird. Can someone give me a thumbs up that we are on? I don't know what happened. This is very weird. Do you see me? Do you hear me? Hi, do you hear me? What happened? This is weird. Never happened to me. It showed me that I'm offline. Can you please write me one comment that you see this? Oh, cool. Thank you, Alex. Oh man, that's difficult. So you saw everything. Cool. Yeah, we are in this, right? So what we will do is that we will say that this buffer, which we have here, is now what would be called, I don't know, write. Let's say we have this function. Maybe we can rewrite it later. So what we pass it is the size. We pass it the current buffer, and we pass it the item we want to add. So this function would be pure, and as a result, because we still need to return something. We don't need to do that, right? That's cool. Because the API doesn't want us to do anything on write, so on write we don't return anything. So that's kind of cool. We can just do this. On the read, it's kind of similar. We don't have any arguments. We just need to return something. What we will do is that we would do here read mutates the array. The buffer. So we will have something very similar like this. But the problem is that the read now has to return, read. But read needs to return the item being removed and the new buffer. So, not sure what would be the best. I would say the best would be that it returns an array of new buffer and the item. This looks kind of good. And yeah, so it writes the buffer to the, as a new buffer and returns the item. Yeah, I think this would be good. Not sure if these methods are real nice named. But yeah, I think it's kind of good. So let's implement first what would be easier. I would say that reading now will be easier. Yeah, I would say that reading now is easier. So how I want it to work. So as I said, I want to implement it as a queue. So this is like when I add one, it will be the first position, then I add two, it will be two. When you read, I remove the element that is there, so I would remove the one, being two on there. When you write again, it just adds 2 and 3 and 4, and then when you read again, it removes the first one. So it's kind of easy. Yeah, I think so. And on the right, I check if it doesn't already have the size. It would violate that, right? So yeah, if the size is not overflown, and on read, I don't need a size. I need to fire an exception when it's already empty. Maybe I can do it here. I don't know. Yeah, I probably should do that because we'll see. So let's see how we would write this function of reading from the array. As I said, doesn't have the size. Alex, I'm not sure about this. We can do it whatever we want. It's actually good maybe to think about it as item because it will follow how we do that, right? So yeah, that's a good one. We can write it like this. I think that Alex already knows how we will implement it, right? So what we do is that we would actually have the first, and we would have tail. So we get the first element and the rest would be an array of tail. And we kind of just return that, right? Yeah, it wasn't that difficult. The question is, now as I look at it, maybe it doesn't make much sense to write it as functional. Yeah, maybe I will. Yeah, come on, guys, this is maybe not that needed, right? Yeah, okay. So this will be much easier. We can write it like this. I'm removing this. Much easier, right? So again, we take the first item from the array, take the rest as the new buffer, we assign that, and return the item. That's cool, that's easy. What about the write buffer? Hi Coach QQ. Not sure what's your real name, but thanks for joining us. So this function needs to receive all these, and it will be hopefully much more difficult. So what we want to do, here we will eventually write some check if the buffer has the size and whatever, I don't know, size is smaller or equal. We'll write it later, we only have to care about the exceptions now. We want to edit, which just means we take what we already have in the buffer and we append the item. That's it, right? That's not that much. So let's see how it goes. I would say that we have this. Oh, sorry, no, we don't have this one, but we have the second one where we don't throw the exceptions. Yeah, man, I don't like to throw exceptions. So we have to do that now, do we? Okay, just for the empty buffer. That, Alex, would be check. I don't know how this works. How do you define a named exception? Is it like this? Oh, sorry. So first we export that, right? I don't know how you do that. It's like a... I seriously do not know how do you work with exceptions? I will have to MDN that as oh sorry, MDN I don't work with that, so yeah. I don't know how to do that. How are you creating your own error? This is stupid. Oh yeah, handling a specific error. No, I want to throw custom error type. That's what I want, right? I guess. Function my error. I don't like that. Yeah, Alex, that's what I would like, but that's, I mean, we want to implement the API they have, and the API says to throw buffer empty exception. And as I look at it, can I do that? I don't know. Oh yeah, I can do this. New error. What? Okay, I will just copy this. I don't know if it works. I hope it does. Yeah, I think I can do that. So, I will see if it works. I probably don't have to have this, right? I don't know, whatever, I don't care about this. Maybe I need this. And here we have to check for that. So if the buffer length is 0, then we can throw the exception. Let's write like this. I think it's written like that. I don't know, whatever. Let's see, and let's run that. What? Oh, sorry. I was in a bring folder and I didn't install that, man. That sucks. Whatever. I'm not sure what you're saying, Alex. We shouldn't change the tests. I mean, we changed the import, but we will not. It's because it just was so annoying. I had to change that. Yeah, come on. This takes forever. Okay. I hope this works. I hate it. Oh, come on, this takes forever. Okay, let's implement the error. What is the error? A buffer full exception. I'm pretty sure it should be the same thing. Oh, but I want this message. Whatever. Oh, cool. So we're testing that. And it failed. Because cannot set property stack of undefined. What is this thing? I hate this. I honestly hate this. Buffer. So I'm sorry. What was this? Throw new my error. Do I have to write something like this? What was that? Yeah, I think it's run. Okay, I don't expect we would be stuck on this thing of undefined. What the hell is this? No, I'm sorry, Kachi, but I can't do that because for some reason it wants this to be exported and then it expects that this one is actually thrown. Oh, but it's like, it calls that? How does it call that? I'm sorry, I don't know what it is. Okay, what I'm doing now, I will just throw an error and deal with this later because this is really annoying. So I just write throw new error. I will do that. When it does, it fails because yeah, it's not a function. So now what I will do, I don't like to do that, is that I will take this back, I will duplicate it, I don't know, write oric and I just say this. Oh, you mean in the function? Oh, can you do that? Okay, I will try what you say. So you say, no, this was the wrong file. No. That here, I can just call new error. That's what you say. Like this. Oh, it passes. Seriously? Okay, thank you. I did not know that. I hate it. But okay, thank you very much. So this seems to be working. I don't know why we passed two tests because there's only one enabled. Let's enable this one, save it, and okay. Oh, sorry, it's no. Something's wrong, right? This is the origin. It's trash. Yeah, we have that. Cool, thank you. Write and read back multiple times. That should also work, and it does. Yeah, because I would say it's better to write in English. Okay. We will get back to the errors. You seem to know what's going on. Clearing buffer, yeah, okay. We can implement this function. That is so straightforward, right? So clean, let's write it here, is function that just assigns empty array to the buffer, right? That's it. Oh, no, and we need a comma here, cool. I will also move this one so it's alphabetical. Save, cool. And yeah, it passes, and then let's try this. Clearing buffer, save. Yes, works. Alternate, read and write, that should be no problem. It is not a problem. Read back all this item. Not sure what it is, it's okay. Rights of undefined role don't occupy buffer. We probably don't have that implemented, and we don't. So null or undefined should not be written. Okay, whatever. So here in the write, what we do is that if the item, I will write it like this. I mean, it's probably the best way how to do that in JavaScript. So if the item, no, I don't like it. Let's write it like this way, because otherwise you would also, yeah, I don't know, it's still bad, but I kind of like this way because it says why you do it. Then you return the old buffer. Save, yeah, it works, cool. Writing to a full buffer throws a buffer full exception. Let's try that. Fails. That's not a buffer full exception. So what would be that? So I will prepare this. Sorry, I have to write it. I need to throw it. I'm still don't know how this works. So if the size is Okay, so what do we have? We have a buffer which has some length. And if the size is already equal to the length, we cannot add a new one because it's already full. I think I'm throwing the error here. I call this, then it's called that. I don't know. We can look at that. But first I wanted to do the functional things and then these stupid things. So ForceRight. Oh yeah, we need to implement ForceRight. Cool, cool. So it will not work now, but we have this ForceRight. So what ForceRight does is that it basically combines read, then write, without checking for this condition. So let's see if we can somehow write it. And ForceRight item. So here, what would be really cool, and then maybe make me to rewrite this again, is that we don't have the function read. It's not like accessible. I mean, we can access it, but it's not very nice. We have the write buffer, but now it checks for it. So what I would do is that I will remove this condition from this write to buffer and move the condition here, which enables us to write to buffer anytime. In the ForceRight, so as I said, what we want to do is first we take the buffer we have, we kind of read, oh sorry, haha, I see that. It only should do that when the buffer is already full, right? Which is the condition we have also here. Okay, thank you Alex for joining. Hope to see you again later. I will abstract that to a new function, which would be isFull, and it's a buffer. It receives the size. So a function that receives size and buffer, and it returns this comparison, right? And I use it in here. Yeah, everything still works. What we do in this ForceRight is that if it is full, that we will like do some magic. And if not, we basically just do what we have here, right? That means we just write that because we can. When it is full, we want to perform a read and then write. That kind of means we will always write, we will always perform this operation. So I will just make it, keep it here because it will always be done. But what I want to do, I will write it, and it's, I kind of want to do this. I will copy that. I know that it's not good to copy things. But if it's full, we remove that. We don't need this item. We just take with our one item, put it as a new buffer, as the current buffer, and then write to it. Yes, yes, that's nice. I think that's good. I will save it. And the force now works. Let's go for the other tests. This works. This works. Yeah, that's it. Okay. So everything's passing. Now we can make the code better. Okay. So what feels weird? I'm still not sure how this should work. This buffer empty exception. So you say I should write throw, when I learn how to write that, new error in here, and then if I understand it, I just call this function like this. No, that doesn't work. That doesn't seem to be working. Or did I do something wrong? I don't know. I will align that because it's annoying and we don't need that. Yeah, there are many things that should work. I don't know why it doesn't work, but I'm kind of okay with this. It's there, it works. So we have some duplications. I'm not that much, but this is basically read and yeah, and we use this write to buffer, so carry different conditions. I like that. This reading, I mean, I would keep it as it is, because this is basically the line does the reading, and I would just abstract that wouldn't help with anything. So I know we technically do have some duplications, but it's not a big one, and it's, as I always say, it's better to have a duplications than wrong abstraction, and I would feel that would be a wrong abstraction. So I like this. We check if it's full. If it is full, we remove one thing. If it's not, we just write to it. And because we know it's not full, we can perform the operation. It's safe. Here we have to check for that. Okay, I think that's it. That was kind of fast, I guess. I will submit the solution. We can look for how others did that, and then we can move for the next one. So Exorcism has this submit function. That's kind of nice as well. We submit that, and we have this. Yeah, I will show it here. So this is the solution we have. Oh yeah, I always forget about this, about the camera. So sorry, I will move it so you see it. Yeah, that's much better, I guess. Maybe you can move it a bit here. What we can do is that we can see ARP's implementation of this, and we can see from that. So I don't know, this guy has 2 iterations. That's interesting. And then maybe we can, I don't know, let's this person, for example. Let's quickly look at that. Okay, buffer empty exception return 1. I still don't know what it is. Okay, I have no idea how this works. And then oh, this is interesting. So this was the first task that didn't ask explicitly for classes, and yet this person like decided to. This is a strange calling convention. Yeah, I mean actually it's much better. Trust me, classes are weird. Whatever. So what we have is in the constructor, he has the capacity, reads, writes, content. Oh, he creates an array. Okay, he reserves the space for that. Then we have the, let's see, read method. If it's empty, which is implemented here, throws that exception. I still don't know how these custom exceptions works. I don't know. And then this converts, contents. This writes modular. Oh, this capacity. Okay, that's interesting. So he actually is making this circle thing. So that's why he has the modular, and he keeps the number of writes. That's interesting. Okay, and yeah, I don't like this, but yeah, he increases that. or I'm not saying he, but I mean they. Then they have, that's right. Read, sorry, is the same thing. It maintains a number of reads. So you have like it's a kind of like circular because you have the modulo and you have like two indexes. One is writes and the other is reads. And you just go and yeah, move them and they go around. They kind of work, it's interesting. Yeah, here if it's full, you read it. If it's empty, you don't. That's cool. A clear, clear makes just reads and writes to go to 0. What is isFull? Oh, that's an interesting function. So isFull is actually determined if reads and capacity together gets writes. So that means the difference kind of from the writes to reads is equal to the capacity. That means that if you would write one more, it would overflow. That's interesting. That's interesting. I can't say I like that solution, but it's interesting. What about this one? Using Q, of course. But that's cheating, isn't it cheating? I'm not sure, and the code isn't much shorter. Yeah, again, I don't know, some magic here. What we have here is that we have the size and then we create a queue. Okay, cool. And then with the queue, it's kind of easy because you can add things and remove things. And you just take care about the size. So this is basically what we did. It's very similar what we did. This is not needed. This part is not needed because he doesn't use a triple equal. But he's using this queue, and I mean, I'm not sure, but it doesn't add much. It just feels very similar to the arrays we've been using. Okay, cool. Okay, that's it. Let's move to the next, and let's see what it is. What is that app? I don't know that, I guess. Spectator. Prime factors, okay, that can be fun. We'll see. Prime factors. Oh. So I will close this project. We've done that already. And then we have a project called prime factor. So let's open the spec, readme, and I will, when I'm at it, create the file because we will need it anyway. And I can close the browser. So readme. Compute the prime factors of a given natural number. A prime number is only evenly divisible by itself and 1. Yeah, evenly divisible. Note that 1 is not a prime number. Yeah, sure. Example. Yeah, I mean, this is like just computing prime numbers. There's a really... I got you. That's funny. I would suggest this app. I don't need it usually because I like this Apple's split window where I'm using. The only thing I kind of would need it as is for adjusting this so you can see it because I have the camera in there, which I usually don't. But yeah, thanks for suggesting. This feels like a normal, creating prime factors. So they're like it was a really, we had it in computer science classes. What was the algorithm called? Some Greek guy. Yeah, I don't remember that. Well, okay. Let's write it from top of our head. Yeah, let's do that. Let's not make it. So let's see the specs. So we know the API. Oh, we have this new. I don't know why. I mean, this is like so wasteful. Why do you create a class which only has one function? Why would you need that? Why would you ever do that? Yeah, I don't know. I don't know. So we will not write that definitely. Okay, let's start. export default. This is the trick which behaves like a class, but it's not a class. We have this for function which receives how we will call it. Let's call it n. It can be easy, right? And what we would do is that we need to find the factors, the primes. So what we will do, this is like the stupidest thing we can do, is that we would create an array which would have the size n-half, because obviously nothing bigger than n-half can be a prime of that number, because it wouldn't be divisible by 2 then. We need to fill it so it's an array we can iterate through. Okay, I will start writing it a little bit nicer. So we will fill it. Then what we do is that we map what we have there, and we receive value which is nothing, and the index, and we go to index plus, we can do index plus 2 because the first thing would be 2, otherwise number 1 is not it's never a prime, right? And now what we do is just we filter those. So we receive this I, and what we do is that we take n modulo I, and we search if this is equal to 0, right? That's it. Let's save it. Okay, first, returns empty array for 1. Okay, that's the next one. that's not like how we should start, right? That's not how you should start. Yeah, invalid array length. What? Let's see if it works for, let's say, this one and maybe this one. Oh no, we need all the factors. I hate this, I hate this. Of course, yeah. No, of course. Yeah, okay. No, I thought it's gonna be, so we need the factors and also factors of those factors. That's not nice. No. Why don't I remember these? It was I totally remember the class we were doing that. Yeah, nice tricks how to go through that. So what we can do, gas. Oh yeah. Oh, I see what is the problem, right? No, I don't actually. I mean, I obviously know what is the big problem. I was thinking about something else. If we do it with 8, we will receive number 4 as well, right? Which is, yeah, we will receive 4. That's stupid. So it doesn't only return prime. So, yeah, so what we need to do is we need to generate only prime numbers, then go through them, and when we find someone which divides it, we need to map it to the number how many times it divides. So what we do next, it will still not work correctly, because we will have to like filter it. Filter kind of is prime. We don't have that now. And then what we do is, again, we receive the I, and then we need to copy that file the many times we have it fits into n. So it's array of the size n divided by I, yes, and we fill it with I. And then we need to flatten that. Oh my god. So because it will create an array of arrays, but we only want array, I mean just one array. So we will, this is like for the reduce, so we will receive pref and next, where the pref would be the first array and the next would be the second, and then we concat that and concat next. That's basically it. When I save it, yeah, you see now we have the 4 there. The 2 would be there 4 times, which is 1 more. Maybe we have something wrong with this. Oh yeah, we should floor it, right? I'm not sure how it works. Let's see. Well, we still get 4. I don't know why. I will look at it later. Maybe it's coming from something else. I mean, just to make it work now, I will do this. Maybe it's actually correct. I always... No, it's not. We have some problems with the number 8. And I'm not sure we need this. I think we don't need this because we already know it fits there at least 1, so I think it should be okay. This concats that, and now we need to write this is prime. Huh. Hi, the DIY resource. Yeah, I have some pretty, like, I think this is the basic stuff you learn at the school, but I don't like to work on that. So you receive a number n, and we can basically do the same thing up to this point, and we want this to be empty, because when it's empty it means it doesn't have any dividers. So we can do that, and I might want to do that now. This is kind of nasty, but it's kind of good to follow that, so I will save it. I can use this filter. Yeah, okay, so what we have here is just like a simple thing that gets prime factors of a number. Yeah, just factors for, I mean prime factors for a number. We receive the number n, we go through it. We need to add the initial value here, interesting. Okay, we do something wrong. Oh no, yeah, this should be exactly 1. Sorry, my bad. Because it means it will include the oh, it can't include the number, right? Can it? Oh, now I'm getting into that. It's, phew, man. Oh, okay. I don't want that. Invalid array length. That's what? Oh, are you kidding me? No. No, it should work. So again, is prime means I will receive n. Then what I do is that I take half of that, I fill it, I map it. Oh yeah, I see that. Yeah, I should not do this. Yeah, as I said, I remember doing this someday, but it would be a good one. I go for it, and the problem here is that I add 2, meaning 2 will always be there. So when I receive n is 2, I will create an array of size 1, which will have 2 in it, which obviously divides the number 2, and then the length will be 1. So I want that. So I will, and this is nested, and I will refactor it later. I will write n is equal to 2, or this thing, and that could kind of work. No, I don't know what it is. Oh, sorry, I need it needs to actually be math.float. I thought you don't have to do that, but apparently you do. You do? What? Oh yeah, and the same on the top. I see that. Sorry, my bad. Let's do this everywhere. That's a little bit nicer. No, I have not. I'm working on it on the spot. So now we kind of have that. It works for these simple things. Let's enable more of that. Let's see, like these, and we will see what are we doing wrong maybe. Okay, all these tests fails because we have way too many. Oh, what I'm doing. Okay, I see the problem. Here I don't want to divide it by that, but I actually want a square root of that, right? I mean, nth root of that. So how many times I can, to which power I can put this number to equal that, and I know there will be this number, which is logarithm, right? Yeah, that's what I want. I will have to. I'm sorry, I have to search for the actual definition of logarithm. I'm never sure about that. So I want a logarithm. This is for base e. I wanna. We can write it. Yeah, exactly what they say here. Yeah. So we will create a new function called logarithm, just called logit. It's yeah. So this is the base and this is the number. That's how it works. And of course we write ECMAScript 6 now, so we can just write it like this. Yeah, cool, we can do this, and we don't have to floor it because it has to fit perfectly, right? And we want to write logarithm of base I for number n. Let's save it. We have something wrong, but okay. So I need a math floor? I mean, that shouldn't be needed. But it's a division, so maybe there could be some. That's a problem with JavaScript, I guess. Yeah, it works now. Okay. Okay, we kind of did what we wanted, but we need to refactor. Oh, sorry, and we have a few more tests. So let's try some bigger numbers. It seems to be taking a lot because we do a lot of iterations, but it shouldn't be a problem for it. This is pretty slow, yeah, obviously. It doesn't make me refactor that it works. Okay, too much. Okay, now we got in some weird loop. We do a lot of loops here, and I mean, I like that because it's a functional way how to do things. It is obviously a little bit slower, but it doesn't mean it's bad. I like it that way, if it will eventually work. So what we have here, we implemented our own logarithm, but the problem with that logarithm is that division in JavaScript can be problematic. So we will round it. So it's always an integer. Okay, now it totally failed. That's bad. I will go through it again, the main thing. So we receive a number n. We take half of it, floor it. That why we do that is because a number can never be, a divisor cannot be bigger than n half. We do this to make it iterable, and we map it to the numbers we have there. We filter to only receive prime numbers. Then we filter those prime numbers that divide the number. Then we have all the factors, prime factors. But the problem is that we need them in also like in the number they fit into that number, right? So what we do is we find the logarithm for that number, and we create an array which has that number of repetitions of the number, and we just kind of flatten that array. That should work. The other problem is that it killed my computer because it's so inefficient on a big arrays. Which is understandable because, as you see, we do this. So like each line here basically means iteration for the whole array, which is still n half, but still it's pretty big. And then we do the same thing almost to define if something is prime, because we do this whole thing. As I said, I like how it's written, but the problem is that it is slow, which is, if I had to write this in a production code, I would definitely change that. But I will not change it now because it wouldn't be that nice. And as you know, readability for me has higher value. Yeah, the prime numbers are the numbers that are divisible only by themselves and 1. They have it here, I mean, for these people who don't remember that. Okay, I want this to stop, okay. Can I at least create I will have to kill it, I guess. Okay, I can go to some other terminal, that's good. Man. Okay, I killed the wrong bash. Okay, my bad. Oh my god, that was stupid. I actually need the node, right? Which one is this? Okay, let's kill this one. We will see what happened here. Let me see. Oh, it was killed. Cool. Oh yeah, my bad. So what I will do is, this is saved. I will disable this big number. This one, it shouldn't be that big, so I will try to test it, and if it passes, I will submit that solution. Okay, that's pretty weird. I mean, if it doesn't, if you can't do this one, it's pretty bad. Oh yeah, sure. I mean, everything we do now is part of, I was saying at the beginning, we are working with this site called exercism.io, where you can have like all the solutions are there. Hi everybody. And thank you for subscribing. Thank you. Resource, yeah, thank you. Hi. Now, I mean, you didn't come in the best time for me. I'm implementing this pretty, I would say, standard algorithm, and I got stuck. I mean, I didn't get stuck, but I just love using these methods, and they are very slow. We all know it. The problem is that I kind of overuse them here to make it look nice. However, for the big numbers, it just doesn't work. I don't want to rewrite this because, as I said, I like functional solutions. And I will just write a comment that I know it's slow. And believe me, I wouldn't write this in the production code. We do this for fun. And I kind of like how here we see how we come to that number, even though that's slow. Yeah, just write a comment. Not sure. I mean, I know that's so nice. We can submit that solution, and we will see. Oh, that was the wrong one. My bad. Sorry. Projects, exorcism, ECMAScript, prime factors, and we can submit that. Prime factors JS. Okay, so here we have this is the solution. This is the link to my solution, and what we will have next is that this is the solution I have. Everybody can see that, everybody can comment on that, but I can see other people's code solutions. Yeah, exactly. I feel the same. I feel the same. Yeah, you can go through and see the problems you have. So let's see. I don't know this person's solution. This person has 3 iterations. So let's see what they did, and we can maybe learn something. Okay. So what do they do is that set the divisors to 2 and factors to an empty array, and then while the number is still bigger than 1, they try to see if the divisor divides the number. If yes, we change the number to be the new one. That means to only include, to be lowered by that factor, and we push the divisor to the empty array. Then we increase the divisor by 1. What I don't see here is that the divisor can actually divide a number more than once, right? That's kind of weird, because if it was number 8, then it should be 2, 2, 2. But here we change it, so the divisor we get here, we push it. Oh, I see that. Sorry, yeah. And then you have if and else. So if it does divide it, we don't change it. Otherwise, we push. So yeah, the divider will be the same and it goes. Okay, that's cool. I mean, this is like a really simple approach, and it works. So that's a good solution. I mean, I don't like the while cycle, as you know. Like it's not functional a way how to deal with these things, but here is pretty useful. Then we have prime factors, constructor. I mean, again, people like to write classes when it's not needed. Result is empty array. I think this is basically the same. Yeah, this is exactly the. Yeah, this is exactly the same. We just do this. Okay, so everybody knows that. Yeah, hi, DIU resource. What I mean when I say functional? Functional means that we can maybe find it. Functional programming is a term of way how to write programs, and the main principle is that functions are pure and they don't have side effects. Oh, that's too much. But as I okay, I will not show this. This is too much text. Maybe we can find a nice image for that. Yeah, this one actually is, I mean, it seems to be simple, but it's actually important. It means a function has 1 input and 1 output. That means it doesn't look anywhere else. It doesn't depend on anything like on a shared state. So it only depends on what you put into it. When we have like a class, it has a state, and therefore it's not functional. So this is one of the concepts. It's pure. The other concepts, yeah, it has like immutable structures and things like that. We want to do that, and we can cover that in some other sessions. Yeah, I will. I'm not sure because if we have enough time, I think we'll. I will stop here. I will close for today. It's been really fun. We did 2 katas. They were pretty. I mean, they took me some time. I mean, I got from this, and I don't work on that very often. So for me, it was sometimes difficult. Uh, but I enjoyed that, and thanks for your contributions. I mean, you helped me with some when I got stuck, and that's what we want to do here. We want to learn together, and I really enjoyed that. Yeah, if you like that, if you want to see more katas doing together and practice, uh, just follow me here on Twitter. I try to do 2-hour sessions like twice a week. And yeah, let me see. Oh, I have a quick question. Can I have many inputs? Yes, yes, of course. I will show you what. Yeah, definitely. That's like, of course, that's the principle. Let me go back to the browser. The input means just a set of things. It can be an object which has some information, right? That doesn't mean it has to be one number or whatever. It can be many numbers. Can be an array, an object which can include other things. I hope I will find some really. I mean, there are many articles, really nice ones, which explain that. But the problem is that I don't want to explain it too much. Yeah, so for example here, Math Max is kind of a good one. You see it has many inputs, but it doesn't depend on anything else. It doesn't depend on the current time. It doesn't depend on how many times you run it or anything like that. Whereas if you have like a function, for example, typical function which is not pure is current date, right? Because it changes every day. Or a random, yeah, that's another non-pure function because every time you run it, you receive a different result. Idea of a pure function is that with the same inputs, it always produces the same output. Therefore, you can easily test it because you just put the set of inputs, you receive outputs, and you can say that it will always do that, and your tests cover it. It's not possible that anything else will change that. Yeah, that's what he says here. I'm trying to, I mean, this is actually a really nice article. I will post this to the channel. You want to read that, I guess, if you are interested in functional programming. I don't have anything prepared for that, so I can't help you. Oh, yeah. Yeah, Dan, you are exactly right. You are exactly right. What you write here is that getting all users from a database isn't pure because it might be different at any given point if someone else signs up and stores. Yes, exactly. Yeah, guys, I mean, that's what I try to write here, functional code. It's a nice one. Maybe next time we can have some more introduction. I can prepare something. I can find some good examples and take something from those articles, which is a lot of text. Yeah, writing to database is, again, I would say time, database are the prime examples of something that changes, right? It doesn't make it, it's kind of, we call it mutation, right? It just changes. And every time you run a function, you can receive different result. So as I said, instead of like, having a function that takes a person and then finds his, I don't know, hobbies, you can have a function that somehow receives a person and then extracts his hobbies just from this object. The good thing is that as I said, when you have a pure function, I mean, in a real world, nothing, I mean, you can't have code which consists only of pure functions. You need to have a few functions where you do these kind of dirty things, right? When you read from the database. But the idea is that you encapsulate it, make it really small, so only this small of the application can, for example, write to the database or read from the database, and the rest doesn't depend on it, and it's very easy to see what these functions do. Yeah, impure functions means you have to think about external things such as what's in my database right now. Yeah, and then you have to, if you have, for example, tests, you need to mock it, right? Or you like, it's difficult for you to change it because you have only one database. It's a really nice topic. I mean, there are some languages which are purely functional. I would say Haskell is like the most well-known example of that. But some languages like JavaScript are like a multi-paradigm languages. That means that you can write it more object-oriented like, or you can use it in a way that is more functional, and that's what we're trying to do here. I'm not sure what you mean. How that first response you looked at was flawed. I'm not sure if I understand that. Okay, so if you are interested in functional programming, that's great. I think that solves so many issues. Like you only focus on small things. You don't have to keep in mind everything else. You just have this function and it does something and you can concentrate on it. That's a great thing. You can always abstract to smaller pieces. Yeah, exactly. What are you writing about? Donald is, yeah, that's exactly the mutation. Maybe I will show you once more why this code, I mean, again, I know it's slow, I understand that, but what you have here is that I create an array and then each line does something with, creates a new array and does something new. So for example, in this line, this one just creates a new array which only consists of numbers that were there and are primes at the same time. This line, again, just takes those numbers which are dividers of the current n, right? And when I'm writing this function, I don't have to think about anything else. I don't have to think about, I don't know, if it's prime because it's already solved somewhere else. So I don't have to think about how to write it. I just focus on this one thing. Then I do the same thing here. Like I do something here, and I know what it is. I focus on it, and I don't have to think about the other things. If you look at the solutions we had there, oh, I closed that. Maybe I have it somewhere still. Oh yeah, here. So this is the solutions of the other guys. And as you see here, you need to know what is the number because you change it, and then how many times you actually run through that. And I think it just is too much in your head. Yeah, for a small piece like this, you can keep it in your head, but for a bigger one, it's pretty much difficult. Yeah. Yeah. Okay, see you guys. It was really nice. See you DI resource. Yeah, so as you say, problem with JavaScript is that the array implementation is kind of slow. There are other libraries that enable some heuristics to be run on it. So these functions could be run a little bit smarter. And it's known that the map and filter, like the one that are integrated into JavaScript, are kind of slow for reasons because it can actually do a lot of things. We use it for kind of a small part, and it needs to also make checks for other things, so it's slow, and I don't like that. Yeah, but this is like a really big example. It's like the first time, honestly, this is the first time I've written a code using this style, and it's really slow. Yeah, that's the first time. It's okay. I love to answer questions. Maybe you've seen that. I like to answer questions. Thank you. Sorry, I like to answer questions. Okay, guys. I guess I will wrap this up. As I said, today it was really nice. I enjoyed that. I hope to do it again. I kind of simplified my setup. I'm not sure if you saw the picture I posted, but I had like high chairs everywhere. It was pretty scary. I will post a picture of how this works. Oh yeah, another question. What do you think about C#? Yeah, I really like C#. I would say if you want to write an object-oriented language, C# would be like one of the best choice. Like Microsoft has been always good at designing new languages. I actually was writing in C# like a long time ago, and I think it's really much a lot of potential. Right now, so many things you can do with that. And if I compare to Java, I think that it's more modern. It has more features, kind of how. And if you want to write some low-level things, like I don't know, maybe games or like some really fast server applications, then yeah, I would say that's a good one. However, I would say if you are a programmer, the actual language isn't that important. Yeah, sure, you know libraries and things like that, but the real beauty lies in exploring many languages. I support JavaScript, right? That's what I have here, JavaScript. And yeah, I would say it's about learning languages, trying new ones, you know, trying some obscure ones, just trying few, I don't know, some exercises, going through tutorials, because each language is usually built around some theme, some idea, and if you get that idea, you can transform it to another programming language, right? Because that's what programming is about. It's about ideas and transformation of data. Yeah, exactly. Every language takes some time to click, and when it does, that's the sweetest feeling ever. Okay, guys, as I said, I had to go. This was really nice. I enjoyed it. I hope to see all of you, or at least some of you, sometime again. And keep some good coding. See you. Bye. Thank you.